In this video, we will look at what is widely considered one of R's greatest strengths, and that is its ability to produce graphics. We'll start with some very basic commands that produce graphics, and then we'll look at some additional features that you can use to improve your graphics. Now, before we begin, I'm going to create more space in the RStudio panes for the script file by dragging the center line over to the left. This is leaving less space for the console and more space for the code. The reason for this is we're not going to be focused so much on creating objects when we do graphics. We're just going to be focusing on the commands that produce code. And as we'll see in a moment, this code is going to create a graphic in another pane in RStudio. Graphics in R works by using commands that produce an R graphics window. And there are lots of different commands that do this. Once you use one of those commands, you can then save the graphic as it is, or you can add additional commands that add additional things to the graphic. For example, let's start with the hist command, H-I-S-T. This stands for histogram. At a very basic level, all that you need to put inside the hist command is the name of the variable for which you want to create a histogram. And so here we see in RStudio, once I use that command, the plot window shows up with that histogram. Another possibility is to do a basic plot of one variable against another. We can use the plot command to do that. In this case, I've got this variable called imprisonment and a variable called crime 1960. These are both out of the crime data set from the last video. And the first one is what's going to be plotted on the x-axis. The second variable gets plotted on the y-axis. And here we have x-axis is imprisonment, y-axis is crime 1960, and with no additional arguments, it produces a scatter plot. Now we'll get to some additional arguments that we can add to hist or plot in a few minutes, but before we do that, I'm going to minimize the plot window, and we're going to take a look at some different text features. That is, text that you can add to your plot. I'm going to start by creating a blank plot. So in this use of the plot command, I'm setting my x variable to a sequence from 1 to 10. My y variable is a sequence from 1 to 10. And then I'm setting the argument type to n, which stands for none, or null. It produces a blank plot. I'm also setting x lab and y lab to blank quotations. That is, no text on the x and y labels. Now I can produce some text with the title command. Inside title, I can type the argument main, which is text that's going to go at the top of the plot to be the main argument, or the title of the plot. This text right here tells R that I want to produce mathematical symbols in this text. Notice I've got the expression command here. Anything I type inside the expression command, R is going to interpret as mathematical symbols or Greek letters. And so this is an example of that here. I've got Greek letters, I've got an equal sign, I've got multiplication. This command sum right here is not sum as we've seen it before that's going to add up a vector of numbers, but is actually the Greek letter sigma that's going to become the summation operator. And then finally I've got this argument called cex.main, and I've got that set to 4. Cex stands for character expansion. So cex.main equals 4 means expand these characters or blow them up 4 times their normal size. Now just in passing, before I actually run this command, I should point out that I could delete all this and simply create normal text by wrapping quotation marks around it. We'll see that in a couple of examples later on. For now, I'm going to use these mathematical symbols. So first I'm going to do my blank plot. There it is. And next I'm going to run the title command with the main argument, and here I have my title blown up very large. You can also use title to add text to the X or Y labels. In this case, the argument is xlab. Notice that up here we set xlab to blank quotations. Now we're going to actually add something to it. And again, I've got the expression command, and this is another mathematical symbol, which we'll talk about a little bit more in just a few minutes. And now I've got this argument cex.lab, and that is the character expansion for the X or Y labels. And I've got that set to 2. And here we have this produced X plus minus Y on the X label. Now there's also a command called text, which allows you to place text in very specific X and Y locations on the plot. The first argument is the value of the x-axis for this text, and the second argument is the value of the y-axis. So I'm going to put this at 3, 4, and again I've got my expression command here. That's my actual text is going to be. And now, since it's just regular text, it's not in a label or the title, I'm just going to use the argument cex. And here we have this text produced. Here's another example at 8, 8. This gets produced up here. Now you may be wondering how you can remember how to write all these different Greek letters and mathematical operators. An easy way to do that is to type demo plot math in your R script. If you do that, you'll see a menu in the R console over here that asks you to type return to start. So I'm going to type return, and then it says hit return to see next plot. I'm going to hit return one more time. And what we see in the plot window is a table with a lot of different mathematical operators and other symbols. The text that's in the light gray tells you what to type into your R script or in your code, and the text that's in the darker shading is what gets produced from typing that code in the light gray. So for example, here's the code right here for typing X plus minus Y. You see that's what shows up, and here in my R script this is exactly what I typed inside the expression command to produce that on the plot. You'll notice also over here in the R console that it keeps saying hit return to see next plot. You can hit return several more times to see different examples of this. There are lots of different mathematical symbols and other operators that you can add into a plot. This is the code for all of that. And then you know that it's finished going through the demo when you see the command prompt here in blue. Okay, now let's go to some examples of adding useful arguments to a plot. I'm going to take that same histogram that we did at the very beginning of this video and add some more information to it. The first thing I'm going to do is to set the margins to be different numbers. The way we do that is with the par or par command. Inside par, I'm going to set an argument called mar equal to a sequence of 4 numbers held together by the C command. This is the size of each margin in the plot that we're about to make. I'm setting the size of the bottom margin to 5, the left side to 5, the top to 3, and the right side to 0.5. That's the order that it goes in. Bottom, left, top, and then right. And I'll let you adjust these different numbers to see how changing them affects the size of the margin. Generally, large numbers mean more white space in the margin, smaller numbers mean less white space. So I'm going to run that command, and notice that nothing happens initially. We'll see this after we actually do this hist command. So notice that this is the same call to the hist command that we did earlier. Got that same variable, %male1424. But now I'm adding some arguments. I'm adding the number of breaks, that is how many boxes to draw with the histogram. I've got an argument called COL, which stands for color, and I'm setting that to gray 50. XLab I'm again setting to blank quotes. Now I'm setting YLab to the text frequency, and notice I've still got that in the expression command. That's sometimes useful if you create a PDF out of your plot, which we'll do in a little while, because that helps the font of the text in the PDF stay true to what it looks like in R. Also got the main argument specified here. This is going to be a title, and I've got cex.lab set to 1.5 and cex.main set to 1.75. And finally, the last argument I'm putting inside the hist command is axes. I'm setting to false. That's telling R not to produce axes in this graph, because we're going to do it on our own. So after running that command, here's what we get. Now let's add some axes. We can do this with the axis command. The first argument that you need is a number, which stands for which axis you're interested in producing. A 1 means a bottom axis, or the x-axis, and a 2 means an axis on the left side, or a y-axis. And I can add the argument cex.axis to again add character expansion. I do that, and here is my x-axis. Notice these numbers are using the cex.axis command. They're 1.25 times the normal size. I'm going to do the exact same thing with the y-axis. Notice I'm putting a 2 here, setting cex.axis equal to 1.25 again. And then I've got another argument called LAS. I'm setting that to 2. That tells R to make the numbers on the axis parallel to the bottom of the graph. If this was set to 1, it would be perpendicular. I like to set LAS to 2 for the y-axis because it makes those numbers easier to read. And then finally, the command box draws a box around the whole thing. So now we've got a histogram with a little bit more information on it. Let's do the same thing to that scatter plot. I'm going to set the margins to something different. This time 5 for the bottom, 6 for the left side, 3 and 0.5. Now I'm going to use the plot command again, but as I did with the last histogram example, I'm going to add some more bells and whistles to it. First argument that I'm going to add is ylim. That stands for ylimit, and there's also an argument called xlim. This is setting the limit on the axis. I'm going to make this y-axis go from 0 to 2000, and I'm representing those numbers by putting them inside the C command. Also going to set the argument PCH. This is the type of point that I want the dots to be drawn as. And 19 happens to be filled in circles. If you recall from our first scatter plot that we created, the points were empty circles. XLab and YLab, as we've seen before, main, as we've seen before, and cex.main and axes, as we've seen before. Here's our scatter plot, and notice that we don't have axes yet because I've got the axis commands coming next. This is the x-axis, as we've seen before, and I've also got code to create a y-axis, as we've seen before. But now notice that I'm adding an additional argument, and that is the at argument. And that's telling R exactly where to put tick marks on this axis. And I'm telling R to put it at a sequence from 0 to 2000 by 200. So at 0, then 200, then 400, then 600, 800, all the way up to 2000. And here we have that axis produced. Then I've got the title command in 2 different forms. One to produce a title on the x-axis, and one for a title on the y-axis. And notice with the code for the y-axis, I've got this argument called line, and that's telling R exactly where to put that text. The larger this number, the further away from the graph that text is going to be. Also notice that this text is coming out of each edge of the plot window. That's okay, because when we save the plot in some way, that's not going to happen. This is just because we've got the size of the window restricted here. And then finally, here's the box command that draws a box around the plot. Now I've got some code here that I'm calling example with lots of features. And this is just a small example that I created that is some fake data about evaluations of the economy by independents, Republicans, and Democrats. It's just to show you a bunch of different arguments that you can use with the plot command. I'm not going to take the time to go through every single one of these because there are so many different arguments, but I encourage you to take this code and run it and look at it and see what those different arguments create. The last thing that I want to do with this video is show you how to create PDFs from your figures. There's a command called PDF which will produce a PDF figure. And the first argument that you add into it is the name of the file that you want to create. I'm going to call this histogram.pdf. And then you can use the argument family to set the font type. I'm going to write Times, which stands for Times New Roman. And then you can adjust the argument's width and height, and those are the dimensions of the figure in inches. If you type this command and run it, you'll see that nothing really happens. That's because you've now told R that you're going to create a graphics command that's going to write to a PDF rather than the plot window. So now I'm just going to type a very basic graphics command, just that hist command that we saw at the very beginning of the video. Notice when I run that, again, nothing happens. That's because we've written that code to the PDF file rather than the plot window. It's only after we type dev.off, which stands for device off, that we stop writing to that PDF. And if we minimize the RStudio window, as you can see, this produced a PDF in our working directory. Here it is, it's called histogram, and this is what it looks like. Those are some of the key basics for using graphics with R. In the next video, we'll talk about doing some programming with R.